Hello. In this video, we will show you an application of how NetSim can be used for network planning and design. Let us consider a simple enterprise network comprising of two branches, a headquarters, and they are connected to a data center over the public cloud. As you can see, we have modeled the network in NetSim by dragging and dropping the network elements and renaming them suitably. Once the devices have been connected, the only configuration that needs to be done is to set the IP addresses and set up different parameters on the devices and links. In this network scenario, we set the link rate for the outbound link, which is link 15, from branch 1 as 2 Mbps, and we configure applications at branch 1. The applications we have created are one FTP flow from system 1 to the file server, a database application from system 2 to the database server, and 8 email applications running between the other branch systems and the email server. We then simulate this network, and once the simulation is complete, we see a set of performance reports. First, let us click on the View Packet Animation link, and this opens out the animation panel where users can see the flow of packets in the network. As you would see, it shows how the network would perform on day 0, with initial OSPF packets being exchanged to set up the route tables. Then before the application flow commences, the 3-way TCP handshake is done, and then you see the flow of different application packets. Next, coming to the reports, let us focus on the delays experienced by the email applications. As we can see, they have an average delay of about 2.9 million microseconds, or in other words 2.9 seconds. Next, let's do something interesting. We add more nodes via a switch in branch 1 and configure 3 of them to run FTP applications. The essence of this experiment is to understand the impact of this additional load on the network. Next, we simulate this and see that the average delay for the email application has increased to 11.4 seconds. Now we change the data rate of the outbound link, which is link 15, to 4 Mbps from 2 Mbps and simulate. Now we see that the average delay for the email application has dropped down to 3.99 seconds. Next, let us go back and set the outbound link rate to 2 Mbps, and from the nodes connected to the switch 1 in the branch, we will run a voice conference call with the head office. The idea of this change is that voice has a higher priority over data, and the routers will first serve the voice packets in its queue and only then route the data packets. When we simulate this and see the application report, we notice as expected that voice calls have been prioritized by the router and the email application starts experiencing significant delays. In fact, the simulation delays are shown as 0 for the email application since no packets were even transmitted. In our last what if experiment, we start the voice calls and FTP transfers at 10 seconds, while the email application runs from time 0 itself. When we simulate this and see the throughput graphs, we notice that email enjoys a good throughput till about 10 seconds, after which it starts dropping. On the other hand, the voice application throughput is flat till 10 seconds since it has no traffic and starts picking up 10 seconds onwards. More sophisticated users may note that these are moving average graphs and not instantaneous value plots. One final feature which would be useful for network engineers is the packet trace. NetSim's packet trace logs the flow of each packet as it moves up and down the network stack in each device and as it flows between the devices. It can be thought of as an amalgamation of Wireshark captures from each device and then combined at a network level. In this trace, you can see the flow of the first data packet from node 12 to switch 10, and then from switch 10 to router 9, and then to router 1, router 2, router 3, router 4, switch 5, and finally to node 6. As the packet flows, a variety of other parameters like timestamps to a microsecond accuracy, payload overhead, errors, etc. are logged for drill down analysis. We hope this video gave you an idea of how NetSim can be used for impact assessment and for network planning. Thanks for watching.